Hello and welcome to yet another video on solving simultaneous equations. Now in this video we're going to look at simultaneous equations where one of our equations is linear but one of them is a quadratic. Okay, so we know that there are two ways to solve simultaneous equations. We can either use the elimination method or the substitution method, but when we've got a quadratic we have to use the substitution method. So what we're going to do is we substitute the linear equation into the quadratic equation. Okay, so notice with this example I've got here, y is equal to x plus 3. So what we can do is in our second equation, instead of writing y equals all of this, we can write x plus 3 equals all of this, because y and x plus 3 are exactly the same. So I'm just going to substitute x plus 3 where y is. So if I rewrite my second equation, I'll have x plus 3 instead of y, and then that equals all of this business. And now whenever we're solving a quadratic equation, we always want 0 on one side. So how can I get rid of this x plus 3? Well, I can subtract x from both sides, and I can also subtract 3 from both sides. So what will I be left with? Well, on the left hand side, I'm just going to be left with 0. And on the right hand side, I'm going to be left with x squared plus 4x and then minus 5. And now I'm just going to switch everything round, so I've got all of this on the left and the 0 on the right. And now let's solve this equation. I can see it factors very nicely. If I think about two numbers that multiply together to get -5 and add together to get +4, well, they have to be, one of them has to be negative because I've got a negative product, but the larger one has to be positive because I've got a positive sum. So the numbers I'm thinking of are +5 and -1. So 5 times -1 is -5, and 5 minus 1 is +4. So I can factorize this expression. I'll just bring it up here. So I can factorize this to x plus 5 in one bracket, and then x minus 1 in my other bracket, and that equals 0. And if you don't believe me, you can expand these brackets out and you will be left with this expression over here. So either one of these, because they're being multiplied together, one of these has to equal 0. So either x plus 5 equals 0, or we can say that x minus 1 equals 0. So if we go ahead and solve these two equations, we're going to have x is equal to -5, or x is equal to +1. So we've done the hard part. Now we just need to substitute both of these values for x into our linear equation to work out the values for y. So when x equals -5, what is our value for y? Well, it's just going to be -5 plus 3, which is -2. And now when x equals 1, we've just got 1 plus 3, which is 4. So our two solutions are x equals -5 and y equals -2, or x equals 1 and y equals 4. Now there are quite a few steps involved in this, which is why it is a grade 8 or 9 topic in your math GCSEs. So first of all, you have to substitute your linear equation into your quadratic equation. Then you have to go ahead and put it into a form that you can solve. And then you have to go ahead and solve this equation. And then once you've solved the equation, you then need to substitute your solutions back into your original equation to work out your other two values. Okay, so it's your turn now. Have a go at pausing the video and solving these two pairs of simultaneous equations. If you do get stuck, you can always go back to my previous example. Okay, so with this question over here, what I'm going to do is I'm going to substitute my expression for y into my quadratic equation. So instead of writing y equals all of this, I'm going to write x minus 5 equals all of this. So now I've got an equation just involving the x's. Remember, I want to get 0 on one side. So if I take away x from both sides and add 5 to both sides, now what am I left with? Well, on the left-hand side, I'm obviously left with 0. And on the right-hand side, I'm left with x squared. And then x minus x, well, those two terms just cancel out. And we've just got -14 plus 5, which is -9. So I'm just going to switch these two terms around again. And now this equation that we have to solve is quite nice because over here we have a difference of squares. This factors very nicely, x squared minus 9. So this factors to x plus 3 in one bracket, and then x minus 3 in our other bracket. Again, you can check this by expanding the brackets, and that equals 0. So we're going to have two solutions, either x plus 3 equals 0 or x minus 3 equals 0. So our two solutions, well, over here we're going to have x equals negative 3, or over here we're going to have x equals positive 3. So now we have our values for x, we can substitute this into our linear equation. Always choose the linear one, it's obviously going to be much easier. So what are our values for y? Well, when x equals negative 3, it's going to be negative 3 minus 5, which is negative 8. Or when x equals 3, we're going to have 3 minus 5, which is negative 2. So our two solutions are x equals negative 3 and y equals negative 8, or x equals 3 and y equals negative 2. Okay, now moving on to this one here. This is slightly trickier than the first one, because here we were told what our expression for y was. Here we've got x plus y equals 5. So we're going to have to get y on its own, or we could get x on its own. And just to make things different, let's get x on its own. So how can I rearrange this formula to make x the subject? Well, I need to get rid of this y, so I can subtract y from both sides. So now I'll be left with x equals 5 minus y. So now we have an expression for x. So we can substitute this expression for x into our quadratic equation. So instead of writing x squared, well, I can now write 5 minus y squared. So 5 minus y squared. And I need to make sure I put it in brackets because this whole thing is being squared. And then we've got plus y squared equals 13. So if I expand the brackets, I'm going to be left with 25 minus 5y minus another 5y plus y squared. So that over here is all of the brackets that I've just expanded. And then we've got plus another y squared, and that equals 13. So we can do a lot of simplification here. So this is going to be 25, and then these two terms will be minus 10y. These two terms, we can simplify it, that will be plus 2y squared, and that equals 13. So now we want to get 0 on this side. So if we subtract 13 from both sides, we're now left with 12 minus 10y plus 2y squared equals 0. And I'm just going to rearrange these terms just so I've got the y squared at the beginning. Now I could solve this equation as it is, but I can see that each term is divisible by 2. So just to make things a bit easier for myself and get smaller numbers, if I divide everything by 2, we'll be left with y squared minus 5y plus 6 equals 0. So now let's go ahead and solve this. And just like before, this expression here factors very nicely. So if I think about two numbers that multiply together to get positive 6 and add together to get negative 5, well, they're going to be negative 3 and negative 2. Negative 3 times negative 2 is positive 6, and negative 3 minus 2 is negative 5. So we can factorize this expression. So this will become y minus 3 times y minus 2, and that equals 0. So we're going to have two solutions again. Either y minus 3 equals 0, or the other solution is going to be y minus 2 equals 0. So what is our solution here? Well, this one is going to be y equals positive 3, and this one over here is going to be y equals positive 2. So finally, let's just substitute these values back into our linear equation. So this time, when y equals 3, well, something plus 3 equals 5, therefore x equals 2. And this one over here, when y equals 2, we're going to have something plus 2 equals 5, so x equals 3. So our solutions for this equation will be y equals 3 and x equals 2, or y equals 2 and x equals 3. Now, this is the last question on this video that I'm going to go through, but as this is quite a challenging topic, I will make another video on this topic, just to give you a bit more practice. So if you would like a bit more practice, please come along and join me, and we'll go through some more of these types of questions. So thank you again for watching, and I'll see you soon. Take care.